Hello everyone, I am glad to see you back on my channel, and today we will continue to solve exercise related to trees. So let's start and let's check first of all the naming of the task. So the task is named, is called validate binary search tree, which is of type medium. And let's check the conditions. So conditions say that we need to design a method that determines if a binary tree is a valid binary search tree, such that the left subtree of node contains only nodes with keys less than the node's key, and the right subtree of the node contains only nodes with keys greater than the node's key. And both the left and right subtrees must also be binary search trees. So we'll need to create a method. Let's say we will call it isvalidatebst. Best is coming BST is coming from binary search tree. Well, like argument, we will send our root node. So the starting point of the tree, which contains all our pointers to our subtrees from the left and right side. And we will return true if the tree is valid BST, and otherwise false, if it's not valid. So if you are not very familiar with what is binary search tree, a valid binary search tree. So in the example below, here we have a valid binary search tree because you can notice that the left subtree contains elements which are equal or less than the root node. So this element can be equal to 20 or maybe less, and the right subtree should be in diapason from 20 or plus infinite, so or greater. So that's the idea of a binary search tree. Now let me show you an example. So here we have a small tree where we have a root 2 and we have a left subtree with one element 1 and right subtree with one element 3. So the algorithm will work in that case that we will use here deep first search. In previous exercise, we also have discovered how we can traverse our tree level by level. This type of traversing is called depth first search, or actually I'm not sure, depth first search. Let me show you. Oh no, sorry, breadth first search. So we will use depth first search, but in the previous exercise we have seen how to use breadth first search, where we traversed the tree level by level. But okay, let's go back to our exercise. So we will use this traversing. We will start from the root, we will go deeper, we will reach the leaf. So it's when the root is pointing to the null. And we will return, in that case, true. Why do we need to return something? And true. Why? What is the reason? So here we have two reasons. First of all, because we use depth first search. We, in that case, will implement it using recursion, and we will need to know when to stop this recursion, because if we don't have any condition, it means that this recursion could be infinitive, and will execute infinitive times. So we need to stop it in one point. And why the condition will be that when we reach the leaf, so when we reach the end of the tree, we need to return true. Because we will put a condition which will check during our iterations and while we will go through our tree, if the node, for example, in left subtree is in diapason minus infinite and 2. And also we'll have another condition for right side, so for right subtree, where we'll check and use diapason from 2 and plus infinite. Yeah, and by doing so, if we will reach the end of the tree and we will not return false, yeah, for example, if this will not be in the right diapason, then in that case, if false wasn't returned, we reached the end of the tree, that it means that all nodes are valid and we can return true. Yeah, so that's the idea, and now let's check the implementation for this algorithm. So let's start to implement this algorithm. I already prepared the signature of the method validate, but without implementation. So let's first of all, yeah, actually here, if you remember, I mentioned that our logic will contain a diapason. So while we will go through our tree, we'll need to check some diapason if a node is included in that diapason. If yes, then we will not return true, and we will not return false, and we will just continue to go through our tree while we will not reach the end of this tree. And if you see here, we don't have some suitable arguments in order to suitable arguments for diapason. So for that case, we will need to create another method which we will use inside this method. So it will be a private method because it will be used just inside this class. It will not be public. Public static also will return boolean, and let's call it is valid bst. Okay, right. And now we will have here 3 arguments. The first argument for our root, and 2 arguments for minimum and maximum in order to form our diapason between minimum value and maximum value. So it will be int, or let it be long min and long max. Okay, perfect. So now inside this method we can initialize minimum and maximum value. It will be like infinite and minus infinite and plus infinite, but because in programming languages we don't have so much memory in order to store minus infinite and plus infinite, because it's an infinite, it's not a fixed number. We will just choose very big numbers between minus and plus. So let's declare these numbers. So long min will be long min value, and long max long max value. Okay, and here we'll use this method is validatebst. We'll put our root like first argument and our min and max value. Perfect. Now we need to here we need to return the value. Value is a boolean, and now we need to write logic for that method. First of all, like always, I suggest you when you use recursion, try to think about the condition which you need to use in order to stop this recursion. And in our case, it will be the end of the tree. So when we will reach the end of the tree, it means that we already validated all the nodes and they are valid. So we can return true. So let's put here this condition. So if not actually root is equal to null, so we reached the end, then in that case we can return true. Perfect. And now let's create that condition which validates the nodes during the processing of the tree. So what will be the condition? So the condition will be that the current node which we want to check should be between the correct diapason. Yeah. So if current node, so let's imagine the first node. Yeah, the first node can be from diapason minus infinite and plus infinite. So just for better understanding. Yeah. So here we put this condition. So our root should be between actually no, if root is less or equal to minimum value, or if our root is greater or equal to maximum value, and here we need to check value but not just a pointer, then in that case we return false. Yeah. And now we need to call this method recursively for right subtree and left subtree. Yeah. So let's do that. Let's call this method recursively for left subtree. So root left, where for this value, yeah, so when we will call this is value bst, we will call this method, and here now we need to define minimum and maximum, because initially it's kind of minus infinite and plus infinite, but for a new value it will be, this diapason will be between, so minimum value will be minimum, so minus infinite, let's say, and maximum value will be the value of his root. Yeah, yeah, because elements from the left side should not be greater than greater, or in our case equal to the root, and we put here this condition. And also we need to call this method isValid recursively for the right subtree. Here also we will use root right subtree, and here that diapason will be between root value, so minimum value, yeah, it's root value, and maximum is plus infinite. So that's the solution. I hope it was clear what I have tried to explain. If you have any questions, please address them in the comments. I will try to help, and we will see in the next video, I would like to say, but actually it's not the end. Also, let's check the complexity. So the time complexity for that solution will be OM, and the space complexity will be OH. So now it's the end, yeah, and I hope we will see you in the next video. Bye.